in presenting your platform at some point to this forum?
Yes, we would most certainly. My co-founder, Steve Hull, will be joining here shortly, but we should definitely look at doing that at a future meeting.
Sounds good. Thank you very much. Please be sure to mark your attendance on the agenda document. I hope you all have links to that. Anyone else who would like to go ahead and introduce themselves? Sure,
I'll do that real fast. Mark Callahan, I actually was at the last security tag meeting. I'm with Strata Identity and part of the Hexa policy orchestration project, and had a couple of follow-up questions for the team after the last call, but also excited to sit in and hear more about today's presentation.
Thank you, Mark. Anyone else? Okay, if not, let's jump into today's agenda. The first one is a GitHub Issue 912, which was a presentation provided by Samuel Otis in June earlier. This is the second part presentation of the same, or discussion around confidential containers. Do you want to go ahead and get started, Samuel?
Sure. Let me
Thank you.
Share my screen. Oh, can you hear me okay?
Yes, we can. Thank you.
Okay.
You might want to start with some context on the previous presentation.
Oh, sure.
Some folks are new.
Absolutely.
Thank you.
It's been 3 weeks, I think. Yeah. So we definitely want to add some context. Too many windows open. Okay. Okay. So some context. We started to present the Confidential Containers project 3 weeks ago. And well, there were a lot of interesting questions, a lot of discussions, and we couldn't go through the entire presentation. So this is a follow-up of this presentation. The first part of the presentation was about was basically a rough or quick introduction to confidential computing. And I'm going to spend 1 minute on this. Hopefully, people on the call are somehow familiar with confidential computing, and if they're not, please speak up, and we can spend a little more time describing what this is all about. But essentially, confidential computing is this here, what I'm describing. The thread model that confidential computing is trying to build is about this. It's really moving a bunch of the software component out of the TCP. And when you run on top of a confidential computing enabled SoC or CPU, you don't need to trust anything in the host, but the hardware and yourself as a guest workload. The firmware, the host kernel, the host OS, the hypervisor, all of those are getting out of the TCP. And you essentially, the claim and the promise is to not have to trust your cloud provider and just yourself. So this is the goal. We went through a little more details on why we want to do this, how we want to do this is about protecting the tenant data, but protecting is not enough. You want to be able to verify that the tenant needs to verify what, how, and where its software stack is running, in order to get a guarantee that the software stack that's generating this tenant data that is protected is the one that it expects. So if you protect data but you don't know how this data is generated, it's kind of pointless. So you need both feature protection and verification. And the next section we talked about was actually confidential containers, which is the project we wanted to present to this forum. confidential containers is really about, at the very high level perspective, is really about taking a Kubernetes pod and running this pod into a confidential computing context, a confidential virtual machine. And with the confidential containers, we are giving each Kubernetes pod its own confidential computing instance. So it's not a bunch of pods running inside a confidential computing virtual machine. You don't share the virtual machine across different pods. Each and every pod gets its own confidential computing VM. Each Kubernetes pod memory and CPU state are encrypted separately from each other. So each and every one of them gets a memory key, an encryption key from the hardware. Actually, the hardware generates an ephemeral encryption key to encrypted memory and CPU state. And each Kubernetes pod software stack is verified. So we get, again, the both aspects of confidential computing, which is protecting and verifying. And last but not least, the container images that the Kubernetes pod is going to be running are also encrypted, and they're protected from the host. We'll see how this is done in a little more details in the next slides. And a very, very important aspect of the project is that we want it to be seamless, and this was a design requirement from day zero with containers, is that you must be able to take your pod definition. You must be able to continue following the same life cycle for your pods. And you must be able to use exactly the same content, unmodified container images, same pod definition, same pod YAMLs, essentially, and you're going to be able to use your pods the same way you're using them without computational computing. So a completely seamless approach where you take your pod definition, life cycles, and content, and you basically run that through a computational computing context. And confidential containers is basically a set of software components, but one of them is a container runtime that sets everything up for you. Okay, so James talked about the threat model. I just want to get to the part that we couldn't really talk about. So this is where we roughly where we stopped, but. What I just said is, well, we want to run a Kubernetes pods in a virtual machine, in confidential virtual machine, and running Kubernetes pod in VMs is kind of something, well, for some of us at least, is very familiar. This is what the Kata Containers project is trying to do. And if you look at how the Kata Containers project does that, basically, we take a Kubernetes pod and we provide a new runtime for Containerd or CRI-O to use. And this runtime will talk to a VMM / hypervisor, depending on how you want to see it, to set a virtual machine up and run the Kubernetes pod inside this virtual machine. So it's pretty close to what we want to do with confidential containers. And basically what we're doing with confidential containers is extending Kata containers to provide the two security attributes that we need for implementing confidential computing, which is protection and verification. So what do we protect? We protect memory and CPU state with the confidential containers runtime. We are enabling memory and CPU state encryption. So we need hardware support for this. We need a hardware confidential computing implementation like SCV or TDX or some other implementation. We protect the container images by not letting the host manage them anymore. And this is a pretty big change for the typical container images management on Kubernetes. We also protect by only using at least signed, or encrypted container images. And we also protect by restricting how the host can interact with the guest through the dedicated Kata Containers API. So we restrict that API to enable that protection. We also add verification to Kata Containers. So with confidential containers, we measure, test, and verify the entire guest stack, so the entire software stack, from the kernel up to the user space software components that runs in a Kata containers guest are measured with confidential containers. And we also provision the Kata guest with the decryption key after the attestation process has been run, successfully run. So the first thing we need to do let me take a step back. Here I'm going to go from what Kata containers provides today and describe step by step how we are going or how we already went from that architecture to the confidential containers one. So this is the current architecture. Obviously, the first thing that we need for implementing confidential containers is a confidential computing hardware. So it's very important to highlight this, because maybe it's not obvious for everyone, but this has a strong hardware dependency. Confidential computing, the attestation part, but also not only the encryption part, but also the attestation part have strong hardware dependencies. So first thing we need is obviously a confidential computing CPU or set of CPUs to start implementing this. And the Kata runtime, when implementing confidential computing, when being confidential containers, start by encrypting the entire confidential VM. So the first thing it does is enabling memory encryption and CPU state encryption. And this is the easiest part of confidential containers, I would say. It's basically a toggle that you set for and that you send to your CPU to say, I want to run this virtual machine, but I want it to be running with memory encrypted and CPU state encrypted. So this is the first step that we go through for implementing confidential containers. And before going further into how we measure, how we verify, and how we do the verification part of the confidential computing, I just want to take a brief detour on and explain what attestation is really about. And I'm going to talk about measurement. I'm going to talk about attestation. I just want to make sure that everyone is somehow familiar with this. So a measurement is really a digest of a piece of data. So here we're going to use a SHA-384 hash function. So we take a piece of data and we hash it, and the hash is actually what we call a measurement. And for doing attestation, we take those measurements, and as you may have guessed, the pieces of data that we're going to hash / measure are the software layers that are going to be a part of the Kata guest software stack. So we take those measurements and we sign them. And once we sign them, we have the ability, or better said, the tenant, the guest owner, the workload owner has the ability to authenticate and verify those measurements. In other words, the tenant is now able to get all those signed measurements, and if it trusts the signers or the signer, it can verify that what's running inside this virtual machine is exactly what is expected to be running. So this is what, in really 1 minute, a very short introduction to attestation, but this is what it's really about: measuring your software layers, signing them with a key that's provided by typically a hardware root of trust. And once you have that, you can provide those set of measurements, those signed set of measurements, and have a tenant verify that this is exactly what it expects. Okay, so now back to the architecture of confidential containers. We have Kata containers now enabling memory and CPU state encryption. And the next thing we're gonna do, and we're gonna do it through a new piece of software called the attestation agent that runs alongside the Kata agent inside the guest. What we're gonna do is measure or ask for a measurement of the entire software stack that's running inside the confidential VM. So everything, including the Linux kernel, the kernel configuration, the command line, the attestation agent itself, the Kata agent, the init_rmfs or initrd, everything is measured, and we get those measurements back from the hardware. So that's the next step. And now that we have measured all our software layers, all our software components, and as part of the measurement, we also including the CPU version and the CPU ID to make sure that the actual hardware platform is also trustworthy. Now that we have those measurements, we are introducing a new entity in this game, which is the what we call a relying party. So this is an out of node, typically out of cluster, out of cloud software component that, as a guest owner, you trust. So you typically either deploy that piece of software outside of your cloud, or you trust a third party to run those services for you. And those services are the attestation services and the key brokering services. And what do we do with those from CATAR, from a confidential continuous perspective? Well, the attestation agent requests measurement from the hardware. The hardware is the one doing the measurements and signing those measurements and keeping those measurements. And the attestation agent talks to the computational computing hardware, gets those measurements back, and sends those measurements to the relying party. If the relying party now is in possession of all the measurements of all the software layers that are part of the confidential VM software stack, and this relying party can verify and compare those measurements against reference values. And if those measurements actually match what the relying party is expecting to get, it can provision the computational virtual machine with typically encryption keys or or secrets, cryptographic materials, secrets, whatever you want, or whatever as a guest owner, as a guest workload, as a workload you need to continue running. So here with confidential continuous, we will ask the relying party to provision ourselves with a decryption key, and that decryption key is used for decrypting the container images. And this is the next step in the confidential continuous architecture. The container images, as opposed to the CATA continuous architecture, where the container images live on the host and are exposed in the guest through typically power virtualization. But they do live on the host, and they are managed by containerd. They are managed in the sense that they are pulled, mounted, and unpacked and mounted on the host. So the host can see anything that's on your container images. And we do not want this to happen with confidential computing. So with confidential computing, the container images are living inside the guest, inside the confidential virtual machine. So the attestation agent is responsible for pulling the container images. And because the attestation succeeded, it now is in possession of a decryption key. And those container images are either encrypted or signed. So depending on either they're decrypted or signed, the attestation agent will either verify those container images or decrypt them with the keys that it got provisioned from the relying party. Here we are taking the example of decryption. So the attestation agent decrypts the container images. Now that those container images, who again are now living inside the encrypted memory that makes the confidential virtual machine, now that they are decrypted, we can start running the Kubernetes pod. And that's basically how we go from CATA containers to the confidential continuous architecture. So there are a few very important steps. I guess the two most important ones, well, there are three very important steps. The first one is that we are running the virtual machine with CPU state and memory encryption, which is a feature provided by the confidential computing CPUs. The next step is for all the software stack that makes the confidential VM up to the attestation agent to be measured by the confidential computing hardware again. The next step is the attestation process, where the attestation agent gets all those measurements, sends those measurements to the relying party. The relying party can verify that those measurements match the reference values, which means that the confidential virtual machine is running a software stack that is exactly what the guest owner, what you as a tenant are expecting. If you are expecting, if the attestation process succeeds, then the relying party can provision through a secure link encryption key or decryption key for the container images. And this is the last step of the confidential containers architecture. The container images are no longer living in the host. They're no longer managed by the host. They're managed by the guest. And the guest pulls encrypted or signed container image layers and can decrypt or verify them with the keys that got provisioned upon successful attestation. So with that architecture, with the confidential containers architecture, we keep the confidential computing promises. With confidential containers, the CSPs can no longer see or tamper with the pods data. They don't see the pods data because the memory is encrypted, and they don't see the container images because those are now living also in encrypted and confidential memory. And the tenant can verify the paths of the stack. So the tenant can verify that the data that is generated and the data that is encrypted through encrypted memory is generated by a trustworthy software stack before actually starting the pod. So we verify that the software stack is the one that we expect before decrypting the container images and before starting the pod. So we protect the data, and we also verify that the software stack that's running the pods is exactly the one that the guest owner is expecting. So with that architecture, the CSP is out of the trust boundary. You don't have to trust the CSP anymore. You can rely on the confidential computing hardware implementation.
Samuel, I had a quick question.
Oh, sure, absolutely. Go ahead. Yep.
My question is, the concern is not the CSP, right? The concern is also the supply chain security, right? All the components so where in the CI/CD pipeline all this validation is going to be done before it is deployed, right?
But that's one concern, yes. But if it is one concern, so this is part of the big equation. This is part of the big problem that we're trying to solve. Obviously, you need to have a secure artifact generation for your software stack if you want to be able to verify it. And so this is something that we're currently discussing, and this is an architecture that we're also designing. It's in the right-hand side there in the relying party. The relying party is provisioned with reference values. So basically hashes of all the software stack, so all the software layers that your confidential virtual machine is going to be running. Actually, let me take that back. Not all the software layers, but just the software layers that make your software stack up to the Kata agent. The relying party is not provisioned with the container images measurement, but it's provisioned with the attestation agent, with the Kata agent, with the kernel measurement, reference value for those measurements, actually. And so you need to hook your CI/CD pipeline where you're building your those pieces of software with your reference value provider, and your reference value provider can be directly hooked to something like an in-toto based CI/CD pipeline, where you get a complete description of your built artifact, and you can then provision your relying party with those descriptions. Once you get the attestation evidence back from the guest, then you can compare those two sets of values. But yes, definitely being able to have a secure supply chain for your software artifacts that are running your guest software stack, again, not the container images, is essential to that architecture. Yes.
Yeah, just picking up. Just going to say, picking up on what Samuel was saying, we're very interested in trying to understand, because fundamentally, as Samuel said, we're introducing this relying party. We're introducing an attestation measurement into the supply chain, which is not there today in what we look at the cloud native supply chain. So we're very interested in trying to figure out, is that significantly different to how the supply chain works in cloud native for container images, etc. today? Is it just another artifact we can treat in the same way? Is it fundamentally a different thing in the supply chain? And I think those are things that we're interested in trying to work out, as well as what Tommy was saying, the technology around which we can control the supply chain around the relying party and the attestation service and things like that.
I just want to call out that the whole relying party key brokering and attestation service is not something that is specific to confidential containers. This is something, it's part of the overall attestation framework that each and every confidential computing implementation relies upon. So there's existing implementation for those. Most of them are not currently hooked into secure supply chain for software. So this is something that we're exploring. But again, the whole attestation framework, key brokering services, the reference values provisioning for provisioning your attestation service with your reference value. In other words, with the hashes, the measurement of the software stack that you're expecting to be running in your confidential virtual machine. This is all something that's been specified and discussed in the overall confidential computing ecosystem. It's not specific to confidential.
Yeah, sorry, Sam, I didn't. Yeah, you're right. I didn't mean to imply that, but it was the CI/CD integration.
Yeah,
that I was talking to you.
Yeah, absolutely.
Hey, Samuel, quick question.
Sure.
On your previous diagram, is it like one pod per VM, or it implies that there are multiple pods can be running inside? Like, just want to make sure that there is no limitations we're talking about.
No, there is one pod per VM. So we are binding a pod to a specific confidential VM. The same way Kata container
it's like a Fargate model, basically.
Yes. Yeah.
Gotcha. What's your thinking behind this? Like, what's your limitations?
The limitation here, when it comes to confidential containers, I think one, if you look at resources, there are two limitations. The first one is the number of memory keys, encryption keys that the hardware is capable of ephemerally generating. So each and every one of the confidential computing implementation, the hardware implementation, have a limit on how many keys they can generate. It's typically on the hundreds of them, and growing with new generation of confidential computing implementation. That's one limitation. Another limitation is encrypted memory, and this is it's a higher limitation than the number of keys. Encrypted memory is expensive. You don't want to waste encrypted memory for storing container images, for example. What I'm describing here, where container images are stored on encrypted memory, is basically our step 0 for confidential containers. We are going with our first release to have an implementation of confidential storage for storing those container images, not on encrypted memory, but on encrypted ephemeral storage, instead of wasting guest memory for a container image.
Yeah.
So those are the two limitations. Yeah, go ahead.
How's there, you talked slightly about threat model, but I haven't been on the last meeting. It would be interesting to read through it, but how the threat model in general would change if you're not using encrypted container images, because it could be just generic container image and a code, but you really the thing I think you care about is basically your application data, right?
Absolutely. Your application data can be part of your container images, and if you don't encrypt those, regardless of who is pulling your container images, it can be the attestation agent or it can be containerd. They go through your CSP's networking fabric, basically. And so if you want to protect something from the CSP, from the infrastructure owner, and that something is part of your container, of your initial container image, for example, a machine learning model or something like this, you want to encrypt those layers. So it's not a mandatory. We don't want to, and we don't require for all layers to be encrypted. But the ones that do carry computational data must be encrypted. The others must be signed. Yeah.
Got it. Yeah. So it's not mandatory. Because like I think I'm like very kind of against the idea of encrypting container images. It comes with like lots of overhead, and you should like distribute your data within images as well. It's like you better get it out of that.
It is quite interesting. It was a conversation we actually went through in the confidential containers project. We started from encrypted containers, but we widened out to recognize that it's protection of something, and that might be data, or it might be, as Samuel said, a model in a container. So the secret there is we're working on the storage and protection of that. It could be the key to unlock the storage because it has a life outside of the confidential VM, in the same way as if you want to protect the container with a life outside the confidential VM, then you might choose to encrypt that instead.
Gotcha. I would love to connect a little bit more, maybe by through LinkedIn or like other channels. And like I have a few folks who I worked with before being like building this type of infrastructure like inside of ByteDance, and they've been like for a while around confidential computing. Maybe I'll ping them if they're interested to participate as well.
Oh yeah, please do. Everyone is welcome. But I just wanted to give. I mean, we've been talking about not encrypting or signing the container image layers. And the alternative is to basically measure those container images before running them and make it part of the attestation evidence that you send back to the relying part, which is for many cases is a reasonable approach. But if you're downloading and pulling multi gigabytes of container images and you want to measure those and extend your measurement with those very large container images, you're talking about a really big latency impact on your on your startup time, for example. So we're trying to avoid this, and we're trying to make the container image outside of the measured parameter.
Yeah, it's like my experience was Fargate is like with even lightweight containers is like 90 seconds, and with all this measurement and encryption, it might take like twice longer, I think, which is like a huge bottleneck if you rolling out a lot.
Yeah, speaking of latency, I was curious whether have you already measured the latency impact by doing the confidential VM, like the way everything is being encrypted and together, as opposed to not doing it?
The latency measurement is really close to the Kata containers one. So it doesn't take a lot longer to start a confidential virtual machine as opposed to a regular virtual machine. And also memory encryption, the memory encryption overhead on the overall performance is very marginal, according to all the silicon vendors, to be verified, of course, but it's very marginal. I think the biggest overhead that you're gonna add to the boot up time and general latency is the attestation process. We need to attest, and we need to attest this software stack, the one that we're measuring, and that goes out of cloud typically when you do remote attestation. So depending on your network latency, it can be impactful or marginal, but that's where the biggest latency is going to come from.
That's cool. Thank you.
Sure.
So if I heard correctly, like if we can run only like one pod per confidential VM, does that mean like we cannot run standard logging monitoring pods just to get metrics and logs from these pods?
Well, it depends on what you want to expose. So typically when you run a separate pod for logging and telemetry and metrics, you're going to use some sort of standard APIs for getting those metrics, which eventually is going to be translated into a runtime call into the workload or a runtime call for building those logging statistics, those metrics. And this is with Kata containers. This is going through the API that's running between the Kata runtime and the virtual machine. Today, this is something that exists, and this is something that we rely on for basically running exactly the same metrics that you would have with the regular containers with Kata containers. If you want, as a guest owner, to expose these through your cloud control plane, you can. As a guest owner, you're responsible for exposing as much of the guest to host API that you want for the Kata runtime to talk to you. So that's something you can expose, or that's something you can decide you don't want to expose, or you can partially expose if you want to, for example, get metrics, but you don't want to have the to let the ability for the infrastructure owner, the cloud provider, to log into your pod. You can have many different ways of, as a guest owner, logging into your pod. But if you don't want to have your infrastructure owner to be able to log into your pod and really introspect your pod, that's something you probably want to disable from the host API.
Right. So, like, apart from the API, typically we would also run like runtime security tools, which are just identifying processes, checking for behavior, things like that. So, can such tools be run on this VM, or is it like because only one pod can be run, other tools will not have like direct visibility into the processes running here? So
if you want to do that through, for example, a sidecar container in your pod, you can do that with confidential containers as long as your sidecar is signed and that the sidecar container is something that, as a guest owner, you accept to run inside your confidential VM. But you cannot have the infrastructure owner say, I want to inject a sidecar pod or sidecar container in my confidential virtual machine without the guest owner consent, not with confidential computing at least. So you can definitely do that as long as the infrastructure owner is choosing a container image that you vet, that you accept as a guest owner, and that is part of your measurement, and that is part of your expected measurement when you do attestation. So it's not impossible; it's definitely doable. This is a use case that is very much common and that we support. But there's some caveat about it where you need to be able to, as a guest owner, verify that whatever gets injected into your pod is something that you expect.
Got it. Thanks.
Sure.
A set of questions. I joined late, didn't catch the project name or the framework name. Would you mind repeating that?
Confidential containers. Confidential containers.
Okay, but you're doing work for confidential containers as a whole, or like this particular project, those extensions you're making to Kata have a different name, or like the components deployed?
Confidential containers itself is a project that's made of a runtime, which is the Kata containers runtime that we are extending. Our goal is to upstream everything. All the extensions that we are adding to Kata containers, we want to push that upstream. But the confidential containers is not only about the Kata containers runtime extension. It's also, as highlighted here, a attestation agent. We have Attestation Services framework that we are also trying to build. We have an image RS, a REST image crate for the attestation agent to be able to pull, unpack, mount container images and run that inside the pod. So it's an operator as well for deploying confidential containers. So it's a set of different components that's part of the confidential containers project, which is a separate project from Kata containers. You can look at confidential containers as a consumer of Kata containers runtime.
Yeah, I put a link into the chat there, Samuel. And one thing you might have not mentioned there is it's a CNCF Sandbox project, confidential containers.
That's right. Yep, it's a very important one. Yes, confidential containers is a CNCF Sandbox project. It's been accepted as such fairly recently.
So I'd imagine this is a question you hear all the time. Then, considering there are other container or other confidential container technologies that are like non-VM based isolation, like running a portion of the kernel in user space, does your roadmap have consideration for adding this other component, say attestation engine onto gvisor, or something that's not in scope at the time?
The gvisor support is definitely not scope at the time. For example, if the gvisor folks want to somehow integrate their runtime and have their runtime supported with confidential containers, I mean, we would welcome that initiative. But we're not planning to support this. We are supporting other runtimes like a runtime called Runny, which is an SGX based container runtime, which is kind of similar to what you're describing, where the isolation is happening at the process level, not at the container level, at the pod level. Sorry. So we are able to support other runtimes like the SGX based one, but that's currently where our scope is terminating.
Cool. Thank you.
Sure.
Do we have any other questions for Samuel?
I left another one in the chat. You had talked about scale limitations. I forget like what order of magnitude you said exactly. Can you run multiple instances side by side?
You mean multiple instances of confidential containers?
Yes.
Yeah, we can run as many as the basically the hard limitation is the number of ephemeral keys that the confidential computing hardware can generate. So if you're I don't know, SCV or TDX implementation only gives you up to 128 keys. This is the number of confidential containers pod that you're going to be able to run. There's one pod, there's one confidential VM per pod, and confidential computing hardware typically generates one ephemeral encryption key per virtual machine. So that's your hard limitation. Again, it's in the range of hundreds of them to be run alongside.
Right, and the calculation of keys is not performed by confidential containers; it's performed by the underlying platform, whatever.
No software layers are seeing any of those keys. They're ephemeral keys kept in the SoC itself. It never leaves. If it does, it's a severe hardware bug, I would say. But yeah, the confidential containers is not seeing or generating any of those keys.
Okay, cool.
One quick question on the for doing the load balancing or the scaling on this running all these confidential containers as well as non-confidential containers in the same machine, perhaps, or the same hardware, there has to be some knowledge by the host about how much loading or how much resources that these confidential containers are taking. Are those parameters or those metrics being provided, even though these are kept confidential and totally under the guest control?
If you're talking, for example, about memory consumption and
right,
CPU
exactly.
Mm-hmm. This is something but the hardware will provide those metrics, so you know how much memory you're going to consume. The kernel will even tell you how much of this memory is confidential, how much is not confidential. The thing that we need to add to the host knowledge is the number of encryption keys that are available and the ones that are left, in order for the scheduler, the Kubernetes scheduler, to know if a node is available for running a confidential computing confidential containers or not. If your node is running out of encryption keys, obviously you can no longer schedule a confidential containers on that node. So we need to expose that as a separate resource, as a separate device resource, for example, in order for the host to make actually in order for the entire control plane, Kubernetes control plane, to make the right scheduling decisions, for example. But when it comes to CPU and memory consumption, this is something that is visible. So you can see how much a confidential computing virtual machine, how much memory it consumes, and what's the amount of CPU cycles that it consumes.
And also, I think the loading that it imposes on the system, as far as whether how many different additional containers you may be able to take in under the same pod or even under the same host. Right?
I don't think there's any. There shouldn't be any difference on how you do that with confidential containers as compared to Kata containers or compared to any other regular container runtime. You're going to be able to run your pod with as many containers as you want, and this is something. It's a problem that lives at the Kata containers layer, not at the confidential containers layers. How do you expose the amount of resources that your pod is now consuming, given that it has an overhead in terms of memory and CPU consumption? And there's an effort that's been recently merged in Kubernetes for describing that overhead when you launch a pod, and you can basically say, I'm expecting my pod to be consuming a little more than what the pod is going to be requesting, because I do have a virtualization overhead, and I'm characterizing this overhead as such and such. And such being an amount of memory and amount of CPU overhead as well.
Right, a little amount of predictability will help, I guess, on the scaling effort, right?
Yeah, that's right.
Right, good.
So yeah, a couple of questions, but I think one of the big ones, you have it up there on your status there of, yeah, I noticed that, confidential containers hasn't had a first sort of release yet. Do you know approximately what the general timeline of that might be?
Yes, we're targeting our first release to be done by end of September.
Okay.
Yep, and this is all tracked on GitHub. It's all discussed every Thursday. We have a meeting if you want to join. But every Thursday we have a meeting, and all the project and the first release that we just talked about is tracked there as a GitHub project. So if you want to get a deeper view on how this is going, you can just go there.
Any areas are requiring help or would like to direct folks' attention to before the release?
The main gap that we have is the secure storage one. We could do a release and technically we have all the components ready to do a release tomorrow, but we don't want to. We would like the first release to be running on top of secure storage. We don't want to have a first release consuming a huge amount of confidential memory, because it's the most precious resource that you can have with confidential computing. So we want to have that implemented, and so this is probably the most critical topic. We do have a proposal and initial implementation for this with DMCrypt and DM Verity. With DMCrypt and DM Integrity for encrypted ephemeral volumes that we would use from the confidential virtual machine to store our container images instead of what we're currently doing, where we store confidential container images directly in memory. So if you want to help, definitely the secure storage implementation and discussion is probably where we need more help. Cool. James, yeah. I don't know if you have other suggestions.
No, I mean, I think the caveat I picked up there was for our first release. I definitely agree with that. I think beyond our first release and going forwards, there's the wider conversation about how the confidential containers project, how confidential computing fits within the cloud native world. So we're very aware of obviously other projects that fall under the security tag, for example. And we are interested in the future beyond our first release, exploring how those fit. You know, is there synergy with what we're doing here? Would something need to change? Is there something different to solve if we're using confidential containers? So beyond the first release, we're definitely interested in that, I think. But for the first release, yeah, I mean, the storage is certainly the technical thing that would be most useful to have an eye on.
Is it technical or is it cost? I know like the cost to turn this thing on AWS is like $500 just to turn a single key.
I think there is definitely, as we look at how we fit in the cloud native world, one of the things we need to focus a lot more on is getting users, getting people to use confidential containers project or other projects and understand the use cases and things like that. And I think part of the challenge, as you say, will be, you know, with us explaining here, and we're talking about putting a pod inside a confidential VM, one of the big questions is, well, does that mean that you put every pod inside a confidential VM? Does that even make sense? And if you don't put every pod inside a confidential VM, how do you secure the communications between them and other pods? Because that will have a direct impact upon the cost of deploying a solution in a cloud.
Yeah, and the cost of you to build and test the project thoroughly, right?
Yes.
Test the
Yes.
release across multiple environments. So
yes.
Having gone through those motions on the projects that I worked on, it's important that you capture that from the onset and open a service desk ticket with the CNCF and say, hey, here are cost estimates to provide support across confidential regions or like top security environments across this cloud providers with this set of requirements, and like give them the support matrix. And they can start to work on that for you. Like the more you give like forecasts and like cost estimates ahead of time, rather than like, oh, we incurred in this cost, can you help us with that? So that's just like one piece of advice. Other than that, everything you've said really resonates. It's directionally correct. Spot on the education aspect of it's not a binary thing. It's not, yes, you're certainly like making all your container deployments, all your Kubernetes clusters confidential. Is like, how do you reason about risk, and how do you identify like risk profiles and reason about like what workloads are you going to make confidential and which not, right?
Yeah, definitely. And to the end of CNCF help, we have recently been reaching out to start to identify for our own CI/CD processes and testing and things like that, trying to figure out. And that is one of the things that came up in a conversation very recently, which was it's kind of we're trying to use hardware that isn't part of what CNCF typically look to provide or understand how to provide at the minute in terms of cost. So that's definitely something that we're looking at just for our own CI/CD at the minute and trying to understand, because there are elements of this that we can functionally test outside a trusted execution environment. And what we don't yet understand is how valid is that testing we do outside the trusted execution environment? How much do we need a real trusted execution environment of all the flavors to actually test? And we do have, I think one of Samuel's charts there did indicate we do have good collaboration from the hardware vendors. So there is an element there that's, you know, you're a hardware vendor of a trusted execution environment. Can you provide a piece of hardware for our pipeline? So there's a bit of that going on, but we definitely are starting that dialogue with CNCF about what it costs and what we need access to. But that, I mean, awesome. All the other projects, yeah.
Happy to lean on us for that to kind of like help provide the justification if need be.
Thanks.
Cool.
Thanks.
That's awesome. We're running out of time. I think there was a few questions on the chat, but I'm not sure we'll have time to take them. If you want to continue the discussion, or if you have more questions to ask, or if you have proposals, suggestions, if you want to help, we do have a Slack channel on the CNCF Slack. I added the link in the chat there. But if you look for confidential containers in the CNCF Slack, yeah, you will find us. So please reach out and let's continue the discussion there.
Great. Thank you very much, Samuel, for the presentation and all the discussion with everybody.
Yeah.
We'll
Well, thanks for letting us present this. This is nice. Nice to talk to you guys.
Thanks.
Perfect. Thank you. Mark, you had a couple of questions.
I did.
Would you like to go next? I know the issue 950 will have to move to next week. Unfortunately, we won't be able to cover it today, but we'll give you an opportunity to ask the questions.
Awesome. I appreciate that. The first question being, we appreciated the chance to present to everybody a couple of weeks ago. We're in the process. This is the Hexa Policy Orchestration project. We're in the process of TOC Sandbox approval. We were referred to you for the security review. We've completed the self-assessment around that, and we wanted to find out who's the POC that we need to work with on the security tag to complete that security self-assessment that we've done.
So Mark, I have replied to Jerry on this as well.
Oh, good. I'm sorry. I apologize. Okay.
He created an issue for that. That issue is going to be picked up by our security assessment team, and they will allocate a resource who will be your point of contact for that.
Wonderful. I appreciate that. And the other, if I may, is simply is being referred to you all by the TOC. What is the process to get back into the TOC Sandbox approval queue, just to get that process going again? We know the next review is next Tuesday, this upcoming Tuesday, I should say. And are there any steps that we do, or is this something that the security tag team does, or what does that look like to get back into the TOC approval queue?
So we don't do TOC approvals. We only do security assessment and security approvals, right? I will point you back to the TOC license Slack channel. Probably you can extend the process, unless Brandon, you know how they can get the approval from the TOC.
Yeah. So again, is this Sandbox or incubation approval?
Sandbox.
Okay. So for Sandbox approval, you kind of would have to just fill in the form and be in the queue. If you feel like it's been picked up or it's been missed, I would encourage to just get in contact with someone on the TOC. So I think like our tag liaisons are Emily and Justin Cormac. So if you feel like it's not being picked up or it's being missed, you can send them a message. I think for Sandbox, it's helpful. You can say like, you've done self-assessment, but yeah, they will be your main point of contacts there.
Very good. I appreciate the information. Thank you.
Yeah.
Any other questions, Mark? Was that it?
I see the issue. I don't see the self-assessment attached. So if you could attach it,
we will attach it. We were holding. We didn't know if we had to wait for the POC to be assigned to us to submit it or not. It's completed. So should we just go ahead and attach it, or should we wait for that assignee from you all? The security.
No, you can go ahead and attach it. Yeah.
Okay, will do. Thank you.
No worries. We are out of time, folks. Thank you so much for the discussion today, and thank you for attending and your participation. Have a wonderful day. We'll talk to you guys next week.
Great.
Thank you.
Thanks.
Thank you. Bye-bye.